Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, and this paper was published on September 25th, 2025, about 4 days ago. The big hook is a concrete way to flag misinformed peer review points, showing that 26.4% of questions and 15.2% of weaknesses are actually misguided. The paper is titled ReviewScore, Misinformed Peer Review Detection with Large Language Models. And as we will see, the approach points to practical quality control for conferences. Beyond the headline, the work introduces an automated premise reconstruction engine, builds a human annotated dataset, and shows moderate agreement between humans and large language models that improves with premise-level checks. Alright, Figure 1 shows the core idea. Flag a review point when a question is answered already, a claim is wrong, or an argument uses incorrect premises. Argument reconstruction means pulling out explicit and implicit premises for checking against evidence. The top panel maps the path from review point to question or weakness, then to claim or argument. The lower strip lists the knowledge sources for judging premises, including the submitted paper and referred papers. Well, Figure 2 shows an automatic argument reconstruction pipeline that turns a reviewer's argument into checkable premises and a conclusion. The top workflow checks validity using first-order logic and a satisfiability solver, which is a program that decides whether the premises must imply the conclusion. The lower text block presents a reconstructed argument that the system streamlines for clarity. The green box on the right lists formulas and keys so the logic can be verified and then translated back faithfully. Alright, with Figure 2 covering the pipeline, Table 1 reports how closely models match human review score labels. Across systems, F1 hovers around 0.5, which signals moderate agreement on the binary decision. Kappa sits near 0.3, so ordinal scoring also shows only moderate alignment. Questions align best while claims fare worst because claims lack concrete evidence. Proprietary models generally edge out open source, with Claude Sonnet 3.7 often highest. So, Figure 3 presents a breakdown of where humans and models disagree on review score. This figure shows that most disagreements stem from misunderstanding or incorrect reasoning, with questions faring best overall. The left panel indicates that claims add value judgments and missing reasons, which raises subjectivity. The right panel compares Claude Sonnet 3.7 to Claude Sonnet 4, and it shows more overthinking for the newer model, meaning the model analyzes too deeply and predicts minority scores more often. So, Table 2 compares base and advanced review score agreements across models. The key point is that advanced scoring, which checks each premise and then aggregates them, delivers higher human alignment. For Claude Sonnet 3.7, F1 rises to about 0.46. That jump is roughly 2.5 times the base. Kappa climbs to about 0.38, which signals stronger consistency on the 5-point scale. Even without aggregation, premise checks help, but aggregation adds a clear boost. So Table 3 compares how often models and humans label review points as misinformed. Overall, models flag about 31% of points. Humans mark roughly 18%. The largest gap shows up for claims at about 23% from models. Humans call only about 6% of claims misinformed. For questions, the model rate reaches about 40%, while human judgments for questions sit near 26%. Wrapping up, 2 takeaways stand out. A sizable share of review points are misinformed, roughly 26% of questions and 15% of weaknesses, and premise-level checking markedly improves agreement between humans and models. The broader implication is actionable tooling for program chairs and authors, helping flag shaky critiques and streamline rebuttals. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.